At BYU, there's a collaboration between the engineering department and the microbiology department. We've developed a new technology, which we call nanoinjection, that allows us to move DNA into cells. The current problem with microinjection is that the microinjection needle, which is the hollow needle to inject the DNA, it is large and it can damage the cell as it actually goes in. So you see a lot of loss of cell life. Because of the engineering, we now have that capability to make really, really small needles. In fact, they're so small, we actually call them lances. So the lance is different than the microinjection needle because the lance is solid. So what's really cool about the technology is that DNA is a negatively charged molecule. And so we could put a positive charge on the lance and DNA will actually collect on the outside of it. And then we could put that lance into a cell and reverse the charge and it drops DNA off there. This has huge advantages. The MEMS system is small enough that we can actually make the lance 10 times smaller than a microinjection needle. And the great advantage of having something smaller is that it will have much less damage as you actually insert it into the egg. It's amazing that we can make something so small. The nanoinjection lance is about 1/100th the size of a human hair. Here you can see how tiny the chip is when you put a pen next to it. And that chip is the one with about 12 to 20 different nanoinjectors on it. There are several applications that will help this to transform the industry. It does give us a new way to actually manipulate DNA to move it to places that we want it. We also can look at genetic disorders, so genes that are defective and how to actually correct those. And this is all because of this new technology.